Good morning, ladies and gentlemen. Today we are looking at circle theorem number 3 that says angles of the circumference standing on the same arc, comma, chord, or segment are always equal. This is one of the more challenging forms because people don't understand what it means to stand on the same arc, chord, and segment. So let's look at these only 2 questions for this micro lesson. So the first one, we have a circle, A, B, C, D. There are points on the circumference, and we're asked to find y, x, and y. And we normally find these alphabetical. So let's look at the first one. Let's look at x. X is the angle that we want to find. But for us to find the angle x, we must first find its formal geometric name. And to do that, we look at the vertex which makes x, which is C, and find where it comes from. So notice it comes from A, it goes to C, then to D. So its true name, as we call it, is A, C, D. And we need to find something that comes from the arc AD that is also found on the circumference. And in this case, there is B. B is formed by starting at the point A on the circumference, goes to B, and then returns to D, similar to what ACD does. So hence, they must be equal. So x, which is ACD, will be equal to ABD, and we notice that ABD has a measurement which is 48. The good part about this theorem is that there is no real calculation. It's basic observation of geometric properties. So hence you don't need to add, subtract, multiply anything. Let's look at the second one. B. So we're looking for the angle y. Again, y is made at a vertex D. But where does D come from? Well, if we follow along, it comes from C. So C, then it goes to D where the angle y is, and then comes way back up to B. So this CD arc, which is in orange, produces the angle y. So the real name for y is CDB. Now some of you are OCD, are compulsive. So you will want to put it in alphabetical order and say BDC. That is still correct. Note the little at, as you guys call it, goes on top of the middle letter, which is where the vertex and the angle is formed. So, is there an angle that comes from B and C? Well, there is. It is called CAB. So, CDB is equal to CAB, which notice that CAB has a measurement, and the measurement there is 35. So, hence, angle Y is going to be 35. Now, let's look at the next one. In this question, again, we have a circle with 4 intercepts, or 4 vertices on the circumference, and we're looking for angle x and angle y. In the first instance, we'll look for x because, of course, we do it alphabetically. So x, x comma, comes from A. So it goes A, B, D. So the true name is ABD. Is there any other angle that is formed by the arc AD? Well, there is. ACD. So ABD is equal to ACD. So ABD is equal to the same value as ACD, which is 55 degrees. Again, as I said, no calculation is needed at this point. These are all by property equal. Let's look at the last angle to find, which is y. So y is formed at the vertex A, but it comes from B. So BAC is the true name for angle y. So this arc BC is what produces the angle. Is there another angle that is produced by BC? There is. It is BDC. So y, comma, angle y, comma, BAC is equal to BDC. So angle BAC is 44 degrees. And there you have it, guys. Theorem 3. The hardest part is to locate the arc which produces the angle in question. After that, there is no calculation, it's purely geometric observation. I thank you. I hope you enjoyed this video. Hope to see you soon.